Hi, hello everyone. So what we're going to have a look at today is we're going to revisit the data types. And there's a number of them on your Leave Insert, okay? And obviously the one that causes the most trouble is the logic, the Boolean, okay? So Boolean data types are ones where there's only two possibilities, a 1 or a 0, a yes or a no, and these are represented by logic gates because there's decisions to be made at each stage of a Boolean sequence, okay? And obviously each logic gate has both a symbol and what's called a truth table, which gives you the possible combinations of what can happen, okay? The truth tables show all the possible input combinations of ones and zeros and all the corresponding out. So we'll go through them all. We'll go through them very quickly because we've done them a few times. Okay, but again, it's good to know them. Now, these are all going to be, I think, in the log tables, if I'm correct, but you still need to know them. Okay, so let's go through the basics. Okay, let's start with the NOT gate. All right, so a NOT gate has an input and an output. Okay, and there's the symbol for it. It's a triangle with a circle on the front. Okay, so what does its truth table look like? Okay, it's pretty easy, in and out. If a 1 goes in, sorry, we'll start with zeros. If a 0 goes in, a 1 comes out. And if a 1 goes in, a 0 comes out. It's sometimes called an inverter. So it switches, okay? It switches what's going on. It gives you the opposite value, okay? It can help to think of the 1 as maybe a true. So if it goes in true, comes out as false. If it goes in false, what comes out is true. Okay, it's the best way of thinking of Boolean trues and false because that's what way you'll use it in Python anyway. But so that's the first one, the NOT gate, and there's its truth table. It's an easy one. Okay, so it's the opposite. The next one we do is the AND gate. Okay, and the AND gate, the symbol is very simple. It's like a D for AND. Okay, so you have input A, you have input B, and then you just have one output. Okay, and again, the truth table for this, because we have two inputs, we have 3 columns, 2 for in, 1 for out. Okay, so in A, in B, and out. Okay, so how do we work it? Well, it's not too hard. If it goes in a 0 from A and in a 0, so both of them are false, the output is also false. Okay, if one is false and one is true, it's also false. If one is true and one is false, it's also false. Which means that the only possibility to get a true output is if both are true. If A and B, that and bit, so both them have to be true. Okay. The way I always think of this is think of it like your Venn diagram. You know, your intersection in a Venn diagram, that's your AND bit. It has to be in both of them in order to be in the intersection. Okay, so that's your AND. And then your third kind of primary one, okay, is your OR gate. Now we're doing the primary ones. I'll do the secondary ones in a second, your OR gate. Okay, so what does your OR gate look like? Well, first of all, it's got 2 inputs and it's got this kind of spaceshipy design. It's more, okay, it's a curvy kind of spaceshipy design with an output. So you have in A and input B. Okay, so what does this table look like? Same as this table in terms of 3 columns. Okay, so we've in A, in B, and out. Okay, so but this time it's one or the other, so we don't need one to control the other. So if both are 0, in other words, if both are false, it's false. If one is true and the other is false, it's true. It's true, and it's true. So there's only one case where it'll generate a false, and that's if both of them, A or B, is false. Okay, so that's quite an interesting one. So there's your three, what I would consider your basics. Okay, there you can build everything from them, or if we use their negated versions, you can negate everything from them. Okay, so your AND, your NOT, and your OR gate. Okay, now when we look at the alternates, that they're kind of, what are their other version? Okay, you can have the NAND. Okay, it looks like the AND, but it's got the 0 on the front of it. Okay, and the AND, so if I go, A, B, I'll just use A, B, and C. Or, it's easier to do it this way, quicker. Okay, so for an AND gate, okay, I should say A, B, and C. Okay, so for an AND gate, a NAND gate, if that's false and that's false, in an AND gate, that would also be false, but in this case, it's true. Okay, if that's false and that's true, it's true. If that's true and that's false, it's true. And if that's true and that's true, it's actually false. So it's a complete opposite of the AND. If we flick back over to the AND only had one possible truth, and that's if everything was true. In this case, it's only got one possible false, and that's if the others are true. So again, it's an interesting one to kind of look at. Okay, very interesting one to look at. The NOR gate, the not OR gate, so that's the NAND, not AND, not OR, okay, not OR, okay. So the not OR gate, let's have a look at it first of all. Okay, looks like the OR gate, so it's got that kind of a spaceship, but it's got the little circle on the front. Okay, so I hope you can all see that. So what does it look like? Let's do it out here, a bit more space. Same thing again, 3 columns. We'll go A, B, and C. Okay, so A, B, and C. So the cool thing about this I always find is you can use the same thing, 0, 0, 1, 0, 0, 1, 1, 1. You can always start off with them because they have to be true no matter what. They're part of any logic gate where you have 2 inputs and 1 output. They have to be there, So what is our NOR gate? Okay, the NOR gate, it's the opposite of the OR gate. So if you look at the OR gate, where is it? Your OR gate only gave a 0 on the 0, everything with a 0. So that means everything gets a 0 apart from the first one. So it's only when 2 things are false that it'll give it to it. Okay, and there is one more important one I am going to do. Okay, and that's the exclusively OR one. Okay, so this is called the XOR, exclusively OR. Now, exclusively OR is just like the OR. It's not like the NOR. It's just like the OR. So if you look at the OR, okay, the OR gate had a 0 when it's all zeros and a 1 when it was all ones, but it also had ones. This one, exclusively OR, is a little bit more finessed, for want of a better word. So the exclusively OR still has the 3 columns like all the other ones. Let's go A, B, and C. Okay, so it still has the 3 columns, A, B, and C. And we're still going to put our numbers in, 0, 0, 1, 0, 0, 1, 1, 1. But exclusively OR will only generate, and this is an important thing, it will only generate a truth. Okay, it'll only generate the truth with one or the other. It won't generate it there, and it won't actually and that's the difference. It won't generate it here. So it's an exclusively OR, and that's a very important ability, for want of a better word. Okay, now remember, where do these exist? These exist, yes, they're mathematical constructs, and they're ways of us translating Boolean data types into machine code. But actually, physically, these do exist as gates, for want of a better word, as they're laid down in the CPU. Okay, this is the whole point of the arithmetic logic unit, the ALU. Okay, this is what it does. These are actually tracks in silicon, okay, that are built to do this thing. So when an electron passes through both of these NAND gates, there's your 2 electrons and there's your 0 coming out, and literally that's what it is happening. Okay, nothing crazier than that. So let's explore this a little bit more. Let's build ourselves some combinations and see what they look like. Okay, so again, what I would encourage you to do is to pause after I've drawn this and to try and draw the truth table yourself. Okay, it's quite important because you will be asked to do this in an exam. So here's one for you. Okay, it's an AND connected to a NOT. So we put in some labels, A, B, and let's see, C. So what we need you to do now is to do out a table. Now I'm going to give you a hint. There's 2 inputs, that's definitely 2 columns. There's 1 output, that's definitely 1 column. But there's also something happening here when these 2 make their decision. So there is actually going to be 4 columns here that you're going to have to draw. Okay, so that's your hint. 3, 2, 1, go. And we're back. Right, so let's have a look. 4 columns. 1, 2, 3, 4. Okay, so let's start. A, B, this is A and B. And then what do you think this one's going to be? C. Could you put it into set, if we were doing set theory, you know, from maths, how would you describe it? If this is A and B here, what is this? Yeah, I hear some of you say it. It's not A and B. So this would be, remember, not from Junior Cert, that little complement. So it's not. So C is actually not A and B. It's not A and B. Okay, so let's have a look and see how we generate this. We'll generate it our usual ways. Okay, if we've only 2 inputs, there's only going to be 4 possibilities, isn't there? It's going to be either 0 and 0, 0 and 1, 1 and 0, and 1 and 1. So let's have a look and see what happens. If I put a 0 and a 0 in there, what does an AND tell me about a 0 and 0? A and B will also be 0. Okay, and if we put a 0 through a NOT gate, what do we generate? A 1. Let's have a look at this one. If we put a 0 and a 1 through an AND gate, you're going to get a 0, which gives me a 1, because it's the opposite through a NOT gate. A 1 and a 0 is the same thing. Now, a 1 and a 1 will generate a 1 through an AND gate, but a 1 going through a NOT gate generates a 0. So there's your truth table for this little combination. Okay, let's try another one. Let's try another one. So here's one that's a bit more tricksy. So here we have an OR gate connected to a NOT gate. We call this A, B, and this C. Okay, I'm going to give you a 3, 2, 1 countdown to give this one a go. 3, 2, 1, go. And we're back. So hopefully you figured out that there was 4 columns. A, B, ARB, and C is really ARB not. It's not A and B. It's not ARB. I want to get all crazy here. Right, so let's see what our options are. So we'll do the usual 0 and 0, 0 and 1, 1 and 0, 1 and 1. Okay, so if it's a 0 or a 0, in an OR gate, you say 0, but through a NOT gate, that becomes a 1. Now, this is not exclusively OR, it's just OR, so that means that's going to be a 1, that's going to be a 1, that's going to be a 1. So if they're all 1s, they're all 0s. So there you go. You've done your first combined multi-stage logic circuit, basically. So there's only a maximum 2 logic gates here, but you know, let's go big, okay? Because there's no point. We're doing leaving cert honors. Let's go big. Let's go for 3, okay? So let's go big. That's an OR gate, and then it's an AND gate and a NOT gate, and we have an output. So let's put in some labels: A, B, C, and I don't know, D. Okay, so sorry, there we go. Now, before we do this, let's just have a think. Okay, let's put this into sets code first. Okay, so what's this going to be? Whatever comes out here has to be A or B, isn't it? Okay, what comes out of here? This has to be not C. And. So D has to be A or B and not C. So that's the set theory, but no, I could actually put it into set code for you. So if you really want me to put it into like set code, A or B, that's it in set code. Okay. But anyway, let's do a truth table. Okay, I'm going to give you a 3, 2, 1 countdown. I want to give you your best shot. 3, 2, 1, go. And we're back. So how many do I need? Okay, so let's think about it for a second. I've got 1, 2, 3 inputs, then they become 2, so that's 5. I've got 1 output, so I'm going to need 6 columns. Okay, so you know there's going to be 3 inputs. Each input can take 2 values, so that's 8 rows we're going to need. So let's try and do this one. Ooh. Okay, so the 6 going in is easy enough. 1, 2, 3, 4, 5, 6. So we've got A, B, C. This is D out here, but we know what D is. And then we've got the A union. We've the ARB here, ARB, and not C. So you can see this is insane. 1, 2, 3, 4, 5, 6, 7, 8. We've got a lot here. Okay, now luckily enough, in an exam you're probably not going to be asked to fill out a full table. They'll probably give you bits of the table and you just fill out the missing pieces. Okay, so listen, let's start off with our very simple things. When they're all zeros, all 3 inputs are zeros. Okay, and then we'll just sequentially go down until we get all 3 inputs are 1s at the bottom. That makes sense to you? So that's what I'm going to do first. I'm just going to fill out these 3 rows because then at least I know what to do next. So we'll start where we make these 2 zeros and a 1. We'll move the 1 this way. 0, 1, 0, 1, 0, 0. And then we'll start filling out more 1s, if that makes sense to you. Okay, so rather than lose track of things, you know? So let's try and do some more. 1, 0, 1. 0, 1, 1. And 1, 1, 0. That should be everything. Okay, now how do I know whether you're right or wrong? Let's count. 1, 2, 3, 4. 1, 2, 3, 4. Should have 4 1s and 4 zeros in each column. Okay, so if A is 0 and B is 0 and C is 0, well, if A and B are 0, what's going to be A or B? It's also going to be 0, isn't it? Okay, so if A is 0 and B is 0, you're going to get another 0 here. Okay, if A is 0 and B is 1, that's a 1. If A is 1 and B is 0, that's a 1. That's a 1. that's a 1, that's a 1, that's a 1. So, interestingly, you only get 2 zeros from the A or B column. Everything else is a 1. Now let's do the not C. If C is 0, that's a 1. It's a 1, it's a 0. If it's a 0, it's a 1. If it's a 0, it's a 1. If it's a 1, it's a 0. A 0. This one's more even, isn't it? Because it should be. So you should have 4 and 4. You do. Okay. Now, this is where it gets fun. Now we're at this point. We are going to apply the AND rule. Remember, the AND rule only gives you a truth, a 1, if both of them are 1s. So 0, 0, 1, 1, 0, 0, 1, 0. And that is a full truth table done out. Okay, you see how logic, no pun intended, you see the logic of doing it this way. Okay, it's really, really handy. If you can just get your basics done, you can then apply the rules as you go along. And that's the beauty of these. Okay, and of course, this all leads to the most important thing, one which we will talk about the other end of it, but I flag it here anyway. We'll talk about the other end of it, and this is the idea of the adding. Okay, so we already know that if you have two binary numbers and you want to add them, adding a 0 and a 0, well, that's going to give you a 0. Adding a 1 and a 0 or a 0, 1 is fine. But it's when the 1 and the 1, okay? When you have a 1 and a 1, it's a 0 and you carry the 1. That's the beauty of it. That's what you're meant to do. But how does the logic gate account for this carry function? Because it understands 1 and 0 and 0, 1. That's fine. And it also understands 0, 0. But how did it understand to carry a 1? So this is how it's built, because you need to know this. This one is very important because it's the basis of addition. And I've talked to you before that when you pare down arithmetic, basic mathematics, every type of mathematics is just a form of addition. It really is. Subtraction is just a form of addition with negative numbers. Multiplication is just addition. And division is just subtraction, which is addition. You know, they're all the forms of addition. So if you can add, you can do anything in maths. So how do they build these half adders that allow this carry function to happen? So it's quite easy once you see it done. There's lots of different ways you could do it. The most common way, though, the one that kind of is using the exclusively OR. Okay, and you can see that because if you have a 1 and a 0 and 0 and a 1, you just want those combinations. Okay, so you use an exclusively OR to create the sum. But most importantly, okay, and this is the important bit, you use an AND to produce the carry. Now I'll show you this by doing out the truth table first. Okay, so there's only 2 inputs, but there is 2 outputs. That's the beauty of this. So you have A and B, and then you have sum and carry. I'll just leave them as sum and carry rather than call them. So we're going to have 1, 2, 3. A and B, sum and carry. So if 2 zeros go in, exclusively OR means you have to have at least a 1 or a truth going in order to make it go through. If it's 2 zeros or 2 1s, it won't work. So there's 2 zeros, so the sum is going to be 0. And 2 zeros going into an AND, you get a 0. So no harm, no foul. Now, interestingly, what happens when you put a 1 in? Exclusively OR will generate a 1. But a 1 and a 0 through an AND generates a 0. So that does what you say. So a 0 and a 1 gives you a 1. Similarly, a 1 and a 0 will also give you a 1. And because it's going through an AND, a 1 and a 0 will give you a 0. You're grand. And this is the beauty of it. This is what makes it so cool. When you have a 1 and a 1, a 1 and a 1 will not trigger an exclusively OR gate. It won't. So you get a 0. And it carries a 1 and a 1, allows a 1 to go through. And that's the beauty of the half adder. Okay? It allows that carry function. And if you can carry numbers over, it allows you to add numbers and do everything that's needed there. Okay, so hope that's helped you kind of understand Boolean logic through the function of logic gates and tables. Thank you very much. Goodbye.